Ladies and gentlemen, hello and welcome. Coming to you not quite live from One Take Studios, where today's topic is scatter plots and trend lines. Alright, so this is just kind of an introduction to the topic. We're not getting anything super crazy. It can possibly get super crazy when you talk about trend lines. You can actually get into calculus and regressions and all that kind of fun stuff. So we're just going to go introductory, surface level stuff today. Alright, so scatter plots, first of all, what are they? Scatter plot is just going to be a graph of points. So if we've got a bunch of points, we have a scatter plot. That's it. Why would we do such a thing? Why do we need a graph of points? Well, its purpose is usually that we are looking for some kind of a relationship. We've got x coordinates, we've got y coordinates. Typically they mean something in a scatter plot. They're not just randomness. And we're looking to see if those two things are actually related or not. What do we call a relationship in math? It's actually referred to as a correlation. Alright, and so if I say that two things are correlated, it means that they are somehow tied together. You want to be careful because we're not going to say anything about cause and effect here. We are just saying that there is a relationship of some kind, but we're not talking cause and effect. Alright, so we have potentially positive relationships. Well, what would that look like? Positive is kind of what it sounds like. Positive talks about things that are positive, up and up, increasing. So what we're going to see for a positive relationship is on the x-axis, the values will increase. And because it's positive, the y values will also increase. So a positive scatter plot might look something like this. And yes, right now this is just me sketching, making up random dots because I can. There we go. Check that out. Isn't that lovely? So what do I see? Do I see dots exactly in a line? No. Is that okay? Yes. But what I do see is that as all of my x values are increasing, so just like we read left to right, as all of the x values are increasing, I can see also that my y values are going up as well. So as these get higher, boom, boom. Alright, so that is the idea of a positive correlation. X increases, y increases, dots are generally going in a positive upward direction. So you can probably imagine then what that means if I have a negative correlation or a negative relationship. Again, this is just me sketching, making up dots because why not? Here we go, boom. You know what? I'm going to get rid of this dot. Let's save that for another thought. Alright, so here's what I've got going on here. Again, this is my scatter plot, and what I can see is that the general trend, if I had to describe it, it's going downward as I read left to right. What does that mean about my x's and y's? Well, again, we always read left to right. So the x values are still increasing. But as I move this way, what happens to the y's? These values are coming down. All right, so for a negative correlation, a negative relationship, we are saying that as the x values increase, the y values are actually decreasing. And so we can see a negative trend. All right, so always reading left to right. Positive is up, negative is down. What does that mean if there is no correlation? Because that's entirely possible. Ladies and gentlemen, here's what I think. I think it looks like somebody just shook up a snow globe. That is no correlation. If I had to draw some sort of line describing this, man, I have no idea which way it would go. This one's kind of going up, this one's kind of going down. What the heck is this? Alright, so here's my what the heck is this. The x's are doing whatever the x's do, the y's are doing whatever the y's are doing, and I can't see any kind of relationship between these two. So we can have a positive correlation, a negative correlation, or no correlation at all. So what does that mean as far as actually putting this in context with things that maybe have a little bit more meaning? Let's try a few examples, shall we? Okay, so trying to decide, do these things, there we go, do these things have a relationship? So example number 1, is there a correlation between empty seats in a stadium and the number of tickets sold? So empty seats versus tickets sold. Let's think about this. If I have my number of tickets and I sell more tickets would be increasing. The more tickets I sell, what happens to the empty seats? The empty seats, as I sell more tickets, would decrease overall. So the more tickets I sell, the less empty seats there will be. More tickets I sell, less empty seats. That would be a negative correlation. Negative correlation. Okay, all right, so that seems like that's kind of logical, right? Hopefully, maybe. If not, I apologize. It's probably my fault. What about unmatched socks versus days since the last full moon? Yes, I said that. Unmatched socks versus days since the last full moon. So I've gone through my laundry and I have 2 socks that don't match each other, but I can't put them together, so they have no matches, so 2 unmatched socks. And let's say the day since the last full moon, man, I'm pretty sure that was like a week ago. So let's say 7. Is there any relationship between these 2 things? No? Probably not. I can't really see that being true. So this would be no correlation. There's nothing to tie these 2 together. Kind of random, actually. Okay, so last one here then, for our examples. Is there a relationship? Is there a correlation between gallons of gas and how much it would cost to fill up your gas tank? Well, so let's think about this. If I have gallons of gas and I buy more and more gallons, so the number of gallons is going up, what's going to happen to the cost to buy those? Well, if I have to buy more, it's going to cost more. So one is increasing, the other is increasing. Now we're talking some sort of positive relationship here. One's increasing, the other's increasing. This is definitely going to be some kind of positive correlation. So hopefully that gives you some sort of idea about what we're talking about here for positive and negative in context. Okay, so I'd like to take this one step farther then and see how this relates to trend lines. Okay, so we've got these examples and I have a beautiful, beautiful graph for you. All right, oftentimes I've actually done this with my students and I've asked them for information. And so what I have here is this graph is a graph about a drive to school. And here I've got the number of miles it takes to drive to school and the number of minutes. And oftentimes when I ask my students, these are just estimations. So that's what I did today for our sake of doing this. Since I couldn't ask you, I'm just doing some estimations. So for example, this one says that if I have 4 miles drive to school, I'm counting by twos. If I have 4 miles driving to school, it'll take me about 7 minutes. This one here says, if I have 6 miles driving to school, it's going to take me about 12 minutes. And this could depend, fast or slow, depending on are you driving through town or are there a bunch of stoplights. Maybe you get to do a whole bunch of highway driving. And so this is not going to be a perfectly straight line, but do you see the trend? What kind of relationship would you call this? Because the more miles you drive, unless you got a serious speed demon in your family, the more time that should take. So we should see a positive relationship here and we can see the upward movement. So what does that mean for a trend line? That means that I would like to draw a line, one line, an actual mathematical straight line through this data that describes what's happening. All right, so we've said, is there a correlation? Yes, we see a positive correlation here. Positive correlation, and we would like to actually draw this trend line. It needs to describe the direction, and I want roughly the same number of points above and below my line. Please do this in pencil. Know that you're not going to be perfect anyways, but please do this in pencil, because once you step back from it, you might change your mind and you might need to adjust it. I have a ruler that is partially see-through. I like this because it's easier for me to see how many points I have above or below. I'm thinking, what do you think? I'm trying to get as close to as many dots as I possibly can. I'm going to try this, and then I'm going to take a look at it. So again, I'm drawing in pencil, and if I like it, I'll go back and do a heavier line for you to see, perhaps. Do I like this? Does this go in the general direction of the dots? Yes. Is it close to the dots? Yes. I've got 3 dots above, 2 dots below. Yeah, one it's kind of on there. That's not bad. Are you going to be perfect in your drawing? No, you're not. Again, we're drawing in pencil. We're just doing a basic introduction things here, and we are not trying to do any calculus. Is there a correct answer? Is there a correct line for this? Technically, there is, and today we don't even care about it. All right, so I think that this is a pretty decent trend line, describing the direction, roughly the same number of points above and below, kind of as close to the dots as I can get it to be. So now, what's the purpose of this? We said the purpose of the scatter plot is to see if there's any relationship. Now I've seen the relationship, and my line describes the relationship, describes the direction. That means that I can now make predictions. And oftentimes this is what math is used for. We collect data and we try to model it and see what we can do with that information. So I'm looking for a prediction. How long do I think that it would take to drive 16 miles? The prediction will be based on the line, not a pure guess. This is what messes up a lot of people, all right? My prediction is going to be based on my line. So I'm going to find 16 miles. So that's 10, 12, 14. Here's 16 right here, all right? That's 16. What I'm going to do is I'm going to follow that line for 16. I'm going to follow that straight up to right here so that I can take a look at what's going on right here. So here's 16. I know you can't really see my line. Followed it straight up, boom. I want to know at 16 miles, what's happening on my line? Well, where do you think that is? If I look at where that point is, right there, all right, so this is my point, right there, this guy here. All right, so 16, well, it's higher than 18. It's not quite as high as 20. Is it close to 19? That's pretty close. It's actually maybe a little bit less than 19. So maybe, as a prediction, maybe I say that my prediction is 18.5 minutes. Again, is this a perfect prediction? No, because it's based on a line that's also not perfect. Is this a good prediction? Yes, actually it is, because it's based on something besides my feelings. I'm not just eyeballing it. I'm saying, here's the line that I drew, 16 miles, trace it up to the line, and then see what's happening. How high is that? All right, so it's above 18, it's below 20, but maybe not quite in the middle, so about 18.5 minutes. That is the goal. And again, most people, if you're going to do something weird and wrong, most people do it right here at the very, very end. The prediction is based on the line. Not your just general eyeballs, not your gut, but what is the line doing at that spot? That's where my prediction comes from. All right? Okay, so have some fun, practice with that a little bit, and I kind of find it enjoyable, but I don't know. Maybe you don't feel the same way that I do. Thanks, guys.